So hello everyone again. This is lecture 2 part 3 of current electricity. In this lecture we will go on with the further discussions after drift velocity, how the resistivity has been what was the origin of resistivity and so on. So I am Samir Lavankar, let us begin our discussion. Okay. So the course outline for you, we started with the introduction concept in which we understood the difference between the movement of charges and the charges being at rest. Then in the electric current and electric current in conductors, we understood the concept of how the electric current is defined as small q by t, and for infinitesimal method we understood this concept as limit delta t tending to 0, capital delta q upon delta t. Then electric current conductors, we defined 3 different ways in which the current is being passed depending on the electric charges being bound or free. If the charges are very free to move, then these are conductors, then depending upon reducing its boundation value, we can get semiconductors and insulators. Finally, in the Ohm's law, we defined that V is equal to Ri, and we got the concept of resistivity and conductivity. Also, there was a relation between capital E and J value, which J rho value, which was being calculated, and that was the end of Ohm's law. Right now, we are in the fifth concept, which is drift of electrons and origin of resistivity. I will try to revise the concept of drift of electrons again. So, finally, what we got was a concept called drift velocity, which was being obtained, and then finally we will use it to find out how was the resistivity being originalized. Okay. So, now let us start with the discussion again directly about drift of electrons and origin of resistivity. So, this thing was being explained in the previous lecture only. There is something called as relaxation time, which is tau, which is equal to small ti by capital N. So, this was the phenomenon of drift velocity. For now, please remember. So, if I try to explain again here. So, if I let me explain by this things only. Okay. So, there is something called as small vi. So, if I make a timeline, small timeline here. So, let us say this is that time t, let us say this is some time t dash, let us say this is that time t I, let us say the velocity is capital Vi here, and let us say the velocity is small vi here. Okay. So, small vi is nothing but the velocity after the collision has occurred. So, let us say this is that point, this is that point at which we are finding out the value of small vi. Then next is that this velocity had occurred at some time t dash. Next is some capital Vi, after which the collision had occurred after some time ti, which is a relation at some time small t. Next is the denotion between the value of velocity at capital Vi and small vi is nothing but the time, which is equal to small ti, hence has been denoted here like this. Next is we got that due to this all ti, so this is for 1 electron. Similarly, there would have been n electrons. So, the value of ti can be calculated by average, which is nothing but summation of ti by capital N, which is called as the relaxation time. So, a concept called as relaxation time was being defined, and similarly using the velocities of capital Vi at different for different electrons per unit so average value is nothing but summation of capital Vi by capital N, which is equal to Vd. And also using a deceleration concept, we understood the formula for small vi, which is capital Vi, which is nothing but small vi minus small e capital E by m into Ti. Hence, using this concept and the average concept, finally we found out the concept of drift velocity, which is small Vd, which is equal to minus small e capital E by m into tau. And hence, using this equation we can directly say that the value of Vd does not depend upon the time, it only depends upon the relaxation time, which is a constant value, which we can directly find out. Okay. So, let us move on with our further discussions for today. So, because of this drift, there will be a net transport of charges across any area perpendicular to E. So, let me change the color first. Okay. So, because of this area, because of the drift, there will be a net transport of charges across any area perpendicular to E. So, if I am making if I am assuming this everything on this conductor here, so there will be a net charges of area through which area, let us say this is that area. So, this is a cross section here, this can be anywhere here. So, this is that area being talked about here. Okay. So, because of the drift, there will be a net transfer of charges across any area perpendicular to capital E. Quite evident, it is perpendicular to capital E, you can see it is perpendicular to capital E. Consider a planar area capital A located inside the conductor such that the normal to the area is parallel to E. So, they are assuming to make a area some sort of like this only. So, consider a planar area capital A located inside the conductor such that the normal to the area is parallel to capital E. Then because of the drift as in drift velocity I explained in the previous part. In an infinitesimal amount of time delta t, all electrons to the left of the area at distances up to small v d delta t would have crossed the area. So, what does it try to explain? If I explain you using a diagram I make here. Let us suppose this is the cross section at let us suppose I make, let us take this much and this is that thing. So, this has been explained here. So, what does it try to say is that let us suppose this has an area A which is capital A and the movement of electrons are in let us say this direction or the electric field is in this direction. Now, then because of drift in an infinitesimal amount of time delta t, all electrons on the left of the area at distance mod of V d delta t would have crossed the area. So, as we know that movement of electron, that is negatively charged particles, is always opposite to the direction of capital E. Hence, if the movement of capital E is in this direction, the value or the charges will move, negatively charged particles will move in this direction. Therefore, what does it try to say is, let us suppose the distance, as we know that the distance is nothing but speed into time. So, what does it say is that the let us say the velocity is drift velocity and we multiply it by time by delta t, then that distance. So, after that time delta t would have occurred, let us say the electrons are at this portion, let us say this line denotes the electrons at this portion, then after that time delta t these electrons would have reached this portion. This is only the concept being explained in the first slide, nothing else. So, there is a movement of charged electrons in this direction at some time delta t. So, this is the explanation being explained in that point. Okay. So, this thing is also been explained, let us move on. If small n is the number of free electrons per unit volume in the metal, then there are small n delta t small v d a such electrons, quite evident, we just need to multiply. So, it is nothing but small n is the number of free electrons per unit volume. So, volume can be find out by using length into area here. So, length into area gives you volume here. If I try to explain, how should I try to explain to you? So, let me take a different color here. So, as you can quite evidently see that if you need to find out the number of free electrons, that is per unit volume. So, if I multiply n with a volume, that gives me the number of electrons which are passing through that volume. So, if I assume this to be that volume here, so quite evident, as we know that volume is nothing but area multiplied by length, and that length can be assumed to be nothing but small v d into delta t. Hence, the value of number of electrons will be nothing but n multiplied with this volume, and this volume is nothing but n into a mod v t delta t, and that is only which is written here, that is n delta t mod v d into a. So, this thing is also been explained here. Next line. Since each electron carries a charge minus e, the total charge transported across this area capital A to the right in time delta t is nothing but minus n e a mod v d into delta t. So, quite evident, the amount of electrons as they are negatively charged, so a minus sign would have been used, and finally we can calculate the value, that is the amount of charge which has been passed from this point to this point in time delta t is nothing but minus n e a mod v d into delta t. It is nothing but multiplication of the complete number of electrons multiplied by charge. Okay. Quite, as E is nothing but the charge per unit what we can say substance or an atom. So, capital E is directed towards the left, and hence the total charge transported along capital E across the area is negative to this. Quite evident, as we know that the electrons always pass in the direction which is opposite to capital E. Therefore, capital E is directed towards the left, and hence the total charge transported along capital E across the area is negative of this. The amount of charge crossing the area capital A in time delta t is by definition I delta t. So, now please remember this substance, this equation also, because now is mathematical formulation. So, see what is it try to say is, first of all we found out that the amount of charge which is moving or transported through that area A is nothing but minus E multiplied by n capital A mod Vt into delta t. Also from the concept of current passing, we know that current passing is nothing but a total charge upon delta t. We know from this expression also, as you can see from this expression also, it is nothing but total charge upon delta t. Hence we can find out the charge in similar sequences nothing but I multiplied by delta t. So both of these say about the charge only, where I is the magnitude of current. Hence in the next expression we will try to just find out the value of equation of both of them. Therefore, I delta t is nothing but n E A mod V t into delta t. I delta t again it is equal to n E A into, we just use the equation of mod V t, which is this expression only. So, hence we got mod V t is nothing but small e capital E by m into tau. Therefore, we can finally find, I will try to explain everything again. So, it is nothing but n E A into small e capital E by m into tau into delta t. This E and this E gets multiplied, hence we will get E square capital A by m. So, E square is used, capital A is used, small m is used into tau n delta t into E. So, this is the expression which we found out, which is same as this expression. Okay. Now, by definition I is related to magnitude mod j of the current density. If we know from the previous concepts of Ohm's law, in the Ohm's law we understood a new concept which is called as current density, which is nothing but complete current divided by area A. So, if we write current in this form, that is nothing but I is equal to j multiplied by A. Using this expression here, using this equation here, we get I delta t equal to, or let me write like this, I delta t equal to j multiplied by area multiplied by delta t. Now, using this equation we can directly find out, if we just remove delta t from here and the value of A from here, we can find out that j is nothing but E square by m into tau n E. This is nothing but this expression here. So, it is nothing but n E square by m. So, it is n E square by m into tau into mod E. So, this is the expression for current density. Now, as just explaining the same concept in vector form as similarly we explained in the previous form. So, the vector j is parallel to E, and hence we can write the above equation in the form j cap is equal to n E square by m tau into vector E. So, we can just put j like this. Here bold letters denote them, but in writing we can't denote by bold letters, so we use a cap sign here. So, this is for vector denotion. Okay. So, now if you previously remember the concept here which we understood previously, we can just use the same relation for the concept of j is equal to sigma E also. If I go back and try to explain from that point only. So, j is equal to sigma E for you. So, j is equal to sigma E. So, just using this expression here directly. So, just using the expression directly here, we can find out that as j is equal to sigma E, hence we can find out that the conductivity sigma can be defined as sigma is equal to n E square by m into tau. And therefore, this is the origin of resistivity. How resistivity has been found out? Resistivity is nothing but 1 by sigma, and this is the complete denotion of, this is the complete circle of how the origin of resistivity has been done. So, using the concept of drift of electrons, we found out the average velocity at some capital Vi, and therefore, using that capital Vi we calculate the value of Vd. Using that value of Vd, we using the previous sums of I delta t, the amount of charges passing through some time delta t through a conductor at some time delta t using a conductor, passage of electron has been done from a point A to a point B in the field of electric field, and if the electric field is present, then we can find out that we can previously use the concept of equation 1 with equation 2 and calculate the value of conductivity as n E square by m into tau. So, a complete circle has been made and the resistivity origin has been finalized. Okay. So, the above equation is similar to Ohm's law, in which we identify the conductivity sigma as sigma is equal to n E square by m into tau. We thus see that a very simple picture of electrical conduction reproduces Ohm's law. So, a simple just explaining this concept here, we can find out the value of electrical conduction which reproduces Ohm's law. We have of course made assumption that tau and n are constant independent of E. So, this is one of the constants in which we are assuming that tau comma n is not a function of E. What is capital E? Capital E is the electric field. So, we have made a assumption that tau and n are constant independent of capital E. So, finally, the complete conclusion of the drift of electrons and origin of resistivity concept is nothing but that drift of electrons has occurred due to the average of the velocities at some time t. Using that concept and the previous concept of Ohm's law, we finally concluded that resistivity is nothing but 1 by sigma, and where sigma is nothing but n E square by m into tau. Now, to explain what are the orders of this electrons drift velocity, I explained you using one of the example. So, please look over the example, is nothing but mathematical calculations only, no such typical things, just please listen here and you will get to know. Also, one of the question has been explained here, that just need to compare what is the difference between, what is the comparison, what is the order of magnitudes of difference such as drift velocity and thermal speed or etc. Okay. So, first of all, the first question says that estimate the average drift speed of conduction electrons in a copper wire of cross sectional area A. So, area A is given to you, let me write it here simultaneously. So, area A is given to you. Next thing is carrying a current of 1.5 ampere. So, current I is given to you, that means the value of J is given to you. If these things are given, so let me write here, so J is also given to you. Assume that each copper atom contributes roughly 1 conduction electron. So, every atom, so for every atom it is saying that a charge has been produced for 1 electron only. The density of copper is this, so density is given to you, that is what we can say mass upon volume is given to you. And the atomic mass is given to you. Question asked is, we need to find out the average drift speed. So, for finding out the average drift velocity is nothing but small e capital E by m into tau. Using another expression here for finding out, using the expression of current, the velocity Vd can be defined as small Vd is equal to capital I by n E capital A. Here the value of small e, you should know this in the previous concept of charges before current electricity, you would have heard that small e has a charge, or electron charge is nothing but 1.6 into 10 to the power minus 19 coulombs. C is denoted by coulombs here. Capital A is 1.8 into 10 minus 9 already given in the question, and capital I is given to you. Now, for the calculation of small n can be calculated using the value of atomic mass and the density given to you. How it has been calculated, please look over here carefully, because it uses a simple concept of Avogadro's law. So, the density of conduction electrons is n is equal to the number of atoms per cubic meter, quite evident, assuming 1 conduction electron per copper atom as is reasonable from its valence electron count of 1. Now, a cubic meter of copper has a mass of this. So, a cubic meter for 1 meter cube value, the mass is given to you as 9 into 10 to the power 3 kgs. First thing. Next is, since one mass of 63.5 grams have 6 into 10 to the power 23 copper atoms. This is a simple Avogadro's law that we know, that for 1 atomic mass, the complete mass is nothing but 6 into 10 to the power 3 kgs. Therefore, we know that 63.5 grams have 10 to the power 6 into 10 to the power 23 atoms. Therefore, to calculate the value of n, we will just need to find out the value of atoms per unit gram and just multiply that by the velocity, multiply that by the density. So, that will be the answer of n. So, as n will be nothing but the value of 6 into 10 to the power 23. So, we will find out what is the amount of atoms per unit mass. So, here per unit mass we will get, and we will just need to multiply by the mass which we are having, that is 9 into 10 to the power 3 kgs. Hence, this will be nothing but the amount of conduction electrons present in the system. So, using this simple mathematical calculation, we will find out the value of small n, which is equal to 8.5 into 10 to the power 28 meter to the power minus 3, and else every value is known to us. Just using mathematical calculation, we will find out the value of drift velocity, which is nothing but Vd is equal to 1.1 meter mm per second. You can see quite slow, very slow speed of drift electron velocity is happening. So, let me stop it here only. I will start with the B part of this in the next lecture. For this lecture, we have concluded with the drift electron concept and how the origin of resistivity has happened. So, let me stop it here only. So, the course progress for you, we started with the introduction concept, then went on with the electric current, then next concept was electric current in conductors. Lastly, we understood the concept of Ohm's law, in which we understood the difference of V is equal to Ri, then using that concept R is equal to rho L by A, then rho was being generalized as equal to inverse of conductivity, and finally we are in the fifth concept, that is drift of electrons and the origin of resistivity. In this concept, we understood the concept of what is Vd, what is the average of capital Vi, and then relating the concept using the Ohm's law concept, and here we found out the relation between conductivity and resistivity, and similarly conductivity and different concepts such as J, rho, L, A, E, etc., M, etc. So, let me stop it here only. We will move on with the further discussion in the next class. Thank you.